Hello everyone, and thank you for joining us today for our webinar. In this presentation, you will be learning all about the advantages of using hand chain operated hoist or chain falls at an angle. Chain falls are mainly used for lifting materials straight up and down, but have you ever considered using them for rigging, tensioning, or drifting a load at an angle? In this webinar, we will discuss ways in which chain falls can be safely used for these types of applications and the advantages they can provide. Presenting today will be Peter Cooke, our training manager covering rigging, hoist, and load securement. My name is Gisela Clark. I'm the e-marketing specialist at Columbus McKinnon, and I'll be your host for today's webinar. We are recording this session today, and the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording, no later than Monday. Everyone is in listen-only mode, so we encourage you to ask questions in the question and answer pane on the right side of your screen. We'll take 5 minutes at the end to answer them. One quick request we have: if there are larger groups of you at one time watching our webinar, please let us know in the comments. Like I said, if we can get a good bunch of you attending, then we'd love to send you something as a thanks. And for everyone else, we're going to have a little follow-up after the session. For those in attendance, we'd like to send you something as well. So let us know who you are, what you're doing when you're in larger groups. The rest of you, we have your information. So yeah, that's it for now. Thank you for your attention, and now I'll turn the meeting over to Peter so that we can begin. Peter?
Okay, welcome everybody, and I'll begin. So today's topics is we're going to cover is safety standards that apply to the hoist, the proper connections for using the hoist at an angle, finding share of load, finding tensions, and then we'll field any questions via the question and answer pane, and we'll try to answer everyone's questions as best we can. And so we'll begin. One thing we do want to note that this is just a brief summary. This is not a substitute for formal training. This is to bring general awareness and safety to the industry. So anytime you have any other questions, feel free to call us or cite look into OSHA or any other industry standards for that information. So first thing I always want to do is I just kind of always talk about the safety regulations and standards. Even though we're going to talk about manual hoist today or chain falls, those fall under the ASME B3016 standard, and within that standard it'll tell you how the inspection criteria, those operator use, some design criteria is in there. So it's a great idea to get that, if you're using the equipment, to have that standard on hand and go over it with your maintenance and operators, and that they have it and understand it, as well as the manufacturer's information or the maintenance manuals and operation manuals from the manufacturer. Those should go hand in hand. As you can see here, the chain falls, they're under the same category as air chain hoist and electric chain hoist and the wire rope hoist. So they all fall under what the category called underhung hoist. Before we want to operate any chain fall, we want to make sure that it's safe to use. And there's two types of inspections. There's a periodic inspection and there are frequent inspections. Periodic inspections are usually or annually. They can be more based on frequency of service, but they are a detailed inspection and a report must be done. And so usually you have a person that is qualified to do that. They've taken training and they know what to look for and how to document it properly. The second inspection is a frequent inspection, we also call it a pre-operational inspection. This type of inspection is done from the floor as best you can see. There's no records kept. So you kind of get to look at what you want to look at or what you can see from the floor. We have a great webinar on this called Pre-Operational Inspections. So it's one we did a couple months ago, and that you can go onto our YouTube channel and get more information on how to conduct that inspection. Okay. And just briefly, this is a checklist that we did from the previous webinar, and I'm not going to go over in great detail, but it gives you a step-by-step of what your operators should be looking for so that they are not going to operate something that's unsafe. So always before you use any equipment, it should be checked to make sure that it's safe, and just a pre-operational checklist that your operator go through. And if something's wrong, they tag it on the service, maybe get a different hoist in place or wait to a qualified person can look at it to determine what's wrong or deem it safe. And again, if you want more information on the pre-operational inspection, please go go to our webinar, go to our YouTube channel, and you can reference that and watch our 30 to, I think it's 30 to 40 minutes presentation that we do on that.
By the way, Peter, if everybody's interested, I'd be glad to, in the follow-up email with a link to the webinar, I can also include a link to that pre-op, that checklist you just showed. During that webinar, we got tons of requests for it. So I'll go ahead and include that just so you know. Okay, thanks.
Excellent. Thank you. Thank you. So let's start using a hoist at an angle. And by the way, this was requested by one of our webinar viewers that say, can you guys do a webinar on how to use a hoist at an angle? And so certainly can. And if there's any topics at the end of this that you want us to look into, we certainly will do that. So one of the big things is, using it at an angle. There's a difference between side loading a hoist and using a hoist at an angle, okay? When you're using a hoist at an angle, what we want to see is bearing point to bearing point, which means hook to hook, that it always remains in a straight line. So as long as that hoist remains in a straight line from hook to hook, you can do that, okay? If the hoist is anchored, meaning the top suspension is anchored and you pull on the chain from one side to the other, that's called a side load, and we really don't want to see that. It's no longer in a straight line. And I'll have some more examples of that as we go through this. So any of those configurations there, as long as your connection points are proper, you can do that. But you need to know some things before you do that. You got to be safe before you do it. So once you did your pre-operational inspection and you deem the hoist as safe, you need to know more things. How much weight are you lifting? That's very important. Where's my center of gravity? What's my share of load on the lift points? And then from there I can figure out my tensions. Now, you may be using the hoist in this manner because you don't know where your center of gravity is. So you're either going to have to know what your share of load is on your connection points or your center of gravity. You're going to have to figure out one or the other. And to do so, you can get scales to do that, or look at prints. If you know where your center of gravity is, you should be able to figure out where your share of load is. And again, we have another webinar that we just did last month on how to, all about the center of gravity and how to calculate your share of load. And so that's another webinar you can watch that goes in great detail on how to do that. So we're kind of tying all our webinars into this one.
You really are this month, aren't you, Peter? Yeah.
Yeah, well, hey, they all go hand in hand. And so you can do a step-by-step. Okay, so here's one application of using a hoist as a compensator. And in this case, you see our hurricane hoist there that's attached to a shackle, which is attached to a nylon sling as a connection point, and then you see a chain sling on the other side. And that whoever's doing this lift wanted to level off the load. One thing you got to remember is that the hoist chain, and I'm talking about the load chain now, not the hand chain, the load chain that's in tension should never come in contact with any object or load. Again, you can see that from bearing point to bearing point, that chain fall is in a straight line, okay? The hoist should only contact your connection point. So you can see we've used a sling. Now slings are meant to be able to do your proper hitch. So you want to use the proper hitch or proper connection with your sling, take your proper reductions with your sling, and choose the right sling for the job. And there you can see we've done that, and we've attached our hoist properly where we're not wrapping the hoist chain around the load. We never want to do that. Use the hoist chain and wrap it around and use the hoist as our connection point. That cannot be done.
Peter, I have a quick question about that one. Can you go back?
Absolutely.
Can you use a lever hoist for that application?
Absolutely can. Yes, a lever hoist. You can, whatever works best for your situation. I prefer the hoist, and I'm really truly not trying to make this a salesy seminar, and I don't do that on these webinars. But that hurricane hoist, I really love it because it articulates the hand chain hoist articulates any direction you want, and you can stand way away from the load and operate it and be safe. It's a safe operation to do that. It's the only hand hoist can do that. A lever tool works just fine as well, and we have another webinar that's basically shows how to do this with the lever hoist. But you got to stand pretty close to the load. You're right up against, because in order to operate that lever hoist, you've got to be right up there against the load. So you do have a little bit more danger involved by doing that. Very good question, though.
Thanks.
What it can be done. The answer to the question is yes, it can. And you would do the same pre-operational inspection with the lever hoist and make it safe, and the same criteria would apply. That straight line pull, and you don't want to connect the chain of the lever hoist to directly to the connections. You want to use proper connecting method.
Okay, thanks.
Look at all these webinars I'm tying in. It's great.
I think you've hit a max this time with weaving them all in.
Yeah, right. But it all goes hand in hand. It's all about rigging. So here you can see, here's a connection point where we're using a beam clamp, all right? And beam clamps are semi-permanent connections for hoist, and they're meant for hoisting the load. Now, a beam clamp can only be, and this is where we call side-loaded, you can only side-load at 5 degrees. And you can see the cones there, that's from left to right, but you have kind of like a 5-degree cone, and that's about all you can do is for a side-load with that type of connection. If you do any more than that, you risk damage to the hoist, you risk damage to that clamp, and so that's going to result in damage and loss of load, which is a dangerous situation. So you need to know your constraints of the connection points you live in. So that would not be, if you were going to, let's say you have a 45-degree angle you needed to the hoist to connect to something, that would not be the right application or right connection. So that's really more for vertical lifting. So here, so what do we do? What do we use, right? And so in this case, you can see here we have an I-beam, and we took a sling and slung it around the I-beam. And what's very important is we need to protect that sling from any surface or edge that can result in damage to that sling. And so I prefer to use engineering padding over something that's, a lot of people will say they use seatbelt material, or they use leather or other synthetic materials of slings they no longer use anymore. There's equipment out there now that's been engineered, that's very safe, that can take the compressive forces that prevent cutting. And so you want to be sure that you protect that connection point. And again, you need to size that sling properly to do that, and we'll get into how to do that. And you can see, the proper connection to the hoist, to the sling, and how we accomplish that. That now allows that hoist to remain in a straight line from pole to pole, so that we can do our proper connections.
I have a really quick question for you. I'm just curious, is there a difference between hoist chain and alloy ringing chain?
Oh yes, absolutely. That's a really good question as well. Yeah, hoist chain and alloy rigging chain are two drastically different types of chain. Rigging chain, we recommend using alloy rigging chain only. There are grades 80, grade 100 out there, and there's even a grade 120 out there. Rigging chain has the ability to stretch 20%, but it's for ASTM standards, 20% before, that's the minimum criteria before it breaks. Now, no stretch is acceptable with the rigging chain. You don't want to see that happen, because that means you severely overload the chain. But it protects the rigger and operator in the event that were to happen. So it's an added safety mechanism that's in place. That's why we only use alloy. Alloy chain can also hold up to abuse, right? It has durability, it has toughness. They have elements in there like nickel, chromium, molybdenum that really makes it a strong for rigging, and can hold up to a lot of use. Hoist chain, on the other hand, is meant for dimensional stability, because we're running over a load sheave or a chain wheel inside the hoist. It does not have the ability to stretch, and so therefore that's why I'm going to go over why it's very critical when you're using a hand chain hoist or a lever tool at angles, that you need to know the calculations and what you're doing and how to size it properly, because it's not going to stretch like the alloy chain. And so that's why I can't come in contact with any load, because you risk, because it's a much harder chain, you risk breaking it, bending it, and jamming up the hoist, or even losing it altogether. So that's why it always got to remain in a straight line and never should come in contact with anything.
Okay.
Hopefully that answered your question for you.
Yeah.
And we use what's called disc grade chain in our CM hoist. It's especially made for our hoist, and we use disc grade. Electric hoists, powered hoists, we use what's known as star grade, which is even harder because it runs at fast speeds over the lift wheel. So there is a difference to that. And we even have webinars on that, on load chain inspection for hoists and rigging chain inspections. There's 2 webinars on that as well. So, I mean, we can go on for hours here on this webinar. That's why I just mentioned that there are those webinars out there, and whoever's on this call today or on this webinar today can go and seek the additional information out if you haven't seen those already. So connections. Let's go. So I'm going back to that example that we showed earlier here. that's the proper connection. But look at our crane hook there. And our crane hook, you can see that on the one side that we're kind of creeping up on the tip there, and so I really don't want that. That's getting a crane hook or any type of hook can only be loaded at a 90-degree included angle, or 45. The sling's coming in at a 45-degree angle from the horizon. So when I set this up, I kind of looked at it and said, no, we're really getting up into the tip there. We're kind of there, or a little bit past it, and I just don't like that connection. And so a better connection so that we don't damage that hook or pull that hook out and cause a tip load is to just place a shackle in there, okay? And again, tying another webinar we did, we have a whole webinar on shackle use and proper uses of shackle. So there's one use of a shackle. A shackle can take a 120-degree included angle, and so we can go at a 30-degree angle from the horizon to there, and so that's a much better connection. It saves our hook, and it's a stronger and more positive connection. And so and you can even looking at it, I'll flip back to the two pictures, it looks a lot neater. And that's the one thing about rigging. It needs to look neat and clean, and if you're hemming and hawing or it looks sloppy, it's probably wrong and you don't have the right hardware.
Hey, Peter, just really quick, we just got a question in from Sean. Is the stretch incurred from the 20% stress easily detected through visual inspection?
Oh, absolutely. Boy, I wish I would have had to. I wish I would have pictures of it. Yeah.
You know what? You can maybe follow up with Sean afterwards and include those. Yeah. I know exactly which one you're talking about.
Yep. And so it's drastically different, and yeah, it'll jump out like a sore thumb.
Okay. Thanks.
And stretch wood, and again we have a webinar showing that on rigging chain inspection that shows it as well. But I'll send Sean that picture. But once you start learning how to inspect chain, it'll even slight stretch will jump out at you. You'll just spot it.
Thanks, Peter.
You're welcome. Okay, so here's a brief example of our webinar from last month about, well, how do we calculate the share load? So if if we know our center, we can do this two ways. If we know our center of gravity, all right, then we can, and we know our total weight, in this case, the total weight is 20,000 pounds, we can figure out what our share load is on each pick point. Okay, well, so I see hoist 1, hoist 2, but it could be on that, if you go back to that picture I've been showing of the structure that was connected to, this is similarly same thing, and so it'll make more sense as I go through this. So we take the overall span between the 2 points and then divide it by where our center of gravity location is from one point, and we can see that it becomes 0.75. So what that tells me is 75% of the loading would be on hoist number 2. Okay, if this was the example that we're showing. So majority of the weight is going to be on that pick point that I'm going to connect to. And so 20,000 pounds times 75% is 15,000 pounds. So if I were to take a scale or a dynamometer and lift straight up on that lift point, that would read 15,000 pounds. And on the other side, it would read 5,000, right? 20,000 minus 15,000 is 5,000. So that would be my shear load on my pick points. Okay, and so that's important to know. And I can work that formula backwards. If I knew what my share of load was, I can work it backwards and find where my center of gravity is, which is good because I want to always rig to my center of gravity. And so we may know that in this case we may know what our share load is and not the center of gravity, and that's why we're using the hoist to do this. But either way, you can work it either way. And again, we go into more detail from last month's webinar on that, and please reference that. Okay, so once we know our share of load, we got to figure out what our tensions are. Okay, so there you can see our shackle and whatever it is that we're connecting to that shackle, as I showed in that previous picture, or hook. We can calculate what our tensions are, and there is what's called a load angle factor. All right, and this is taken from the CM Rigging Pocket Guide. And depending on you figure out what your angle is, and let's say you have a 30-degree angle, and if it was hoist number 2 in this case that was at that 30-degree angle, and we just said it was 20,000 pounds, you would have to, or excuse me, it was 15,000 pounds. You would have to take that and multiply it by 2, and have to size that sling up for a 30,000 pound load, because that's the tension that it would see. Okay, if you're unsure of what your angle is and you want to be more precise, And then you go to what's known as the tension calculator. And again, we walk you through it in our rigging pocket guides, and it walks through it. But basically, it's your sling divided by your height. And what I teach people to do is, it's kind of sometimes impractical to measure out your total sling length and your height. It gets kind of, because it can get kind of high, and you don't get accurate measurements. But all you're really doing is making a right angle triangle. So if you just take the S dimension, and I always like to use 24 inches because it's easy for me to remember. So I take my tape measure and measure up from the connection point up that sling 24 inches, and then I drop that tape measure straight down like a plumb line. And where it comes, where if you drew a straight line across from the connection point, that's going to be your height dimension or your H dimension. So you do S divided by H. That'll give you that LAF, that load angle factor from that chart that we're seeing off to the left there. You can actually pinpoint your load angle factor from there, and then you multiply that by your share of load that you've come up with. So now you know, so again, now you know, do I have the right equipment placed? So you can see how important it is to really sit down and figure out your center of gravity, your share of loads, and kind of have an idea. A lot of people may be doing this practice and not really, they know what their weight of the load is, but they're not sure of their center of gravity, so that's why they use the hoist, and they go and they do it. They've been doing it that way for a long time. You may want to take a step back and say, oh, well, do we have the right equipment in place? Because it's very easy to overload at that point. And so these are the steps, you know, kind of a little bit of a rigging plan you should take. And I do also want to make note that, and these formulas that we're showing here, that the pick points are on the same level. And if you have off-level pick points, it changes up a little bit as far as the tension. You still have the same load angle factor, but how you figure out your tension is a little bit different. It goes just way too complicated for this short webinar, and that's something we would teach, you know, in our rigging courses. We have, you know, qualified rigger courses to do that, but this is for level pick points or pick points on the same level. And then we have here what's known as load drifting, another way to use hoist at an angle. And so here's where, you know, you wouldn't want to use beam clamps to connect to the top girder, or the picture that I showed where you take a sling and you wrap it around the I-beam and you use the sling protection. You certainly want to do that to protect your sling. And again, you know, there's engineered padding and Kevlar, and so you want to look into that. The engineered padding that's the one, you know, it's meant to prevent cuts. A lot of people will use steel pipe and cut the pipe so it fits over the flanges of those I-beams. That's a pretty good. And then I had a slide a couple slides ago that showed like a metal mesh sling encased in Kevlar. That works very well. But sometimes there's like Kevlar sleeves. That's all they are, is Kevlar. It's not the greatest. You know, in some situations it may work, but in other situations it won't. So I use those Kevlar sleeves that just for more abrasion resistance, and you know, that's going to prevent the sling from getting damaged from rubbing or when it's tension rubbing up against the load. But I really like more like the steel on steel or steel pipe, metal mesh encased in Kevlar, or the engineered pad, which conforms around corners and doesn't allow the sling to ever come in contact with corners. There's also urethane, special manufactured urethane pads like magnets that you can stick around those corners. The biggest thing is protect those slings. You could even have somebody weld up a block of steel, then drill it out and connect a swivel hoist ring to the bottom of the I-beam. And again, you would want a qualified person to evaluate the I-beams you're connecting to be sure they have the strength to hold up what you want to do to it. So a lot of times we see drifting loads like this is you're removing a piece of machinery from an area that is non-accessible to a crane or an overhead crane or a tow motor that you just can't get to it. So the only way to do it, usually it happens in a pit where you got to pull motors and things of that nature. So you use two hoists and you kind of drift the load. You raise both hoists up to a certain level that you need it, and then one person will lower and one person will raise, and you can keep it at the same level and drift it over into a position where then maybe you can get a tow motor or an overhead crane in place to move that equipment. And there is a formula for that, and you see the formula to the right there of how to do that. And you may have to raise it and lower it in certain levels to get over. You can see the obstruction here. So you want to find your worst case scenario and usually your worst case scenario is going to be at your highest height, because that's going to create your shallowest angle up on top. and you want to make sure that the equipment is sized properly at that position. And so you can kind of take, if you can kind of pre-plan it out, take a half hour, and before you go and just rush and do it, be sure that you put the right equipment in place. And again, there's the formula there that we supply. It's in our rigging pocket guides that we have. And then those two were, that formula is for connection points at the same level. Okay, and for this presentation, we're only showing that because it gets a little bit more complicated when you have off-level pick points, and it just changes the tensions up a little bit. And so if you have that, seek a qualified rigger, or to look at that for you. And really, it is the qualified rigger that should be performing these operations. This is more of what we're showing here today is advanced rigging. So basic rigging training really is not good enough to do in these instances. So someone needs some advanced rigging knowledge to understand how it is they need to accomplish these types of lifts and calculate tensions.
Yep, Peter, I'd like to go ahead and do a quick polling question, if you don't mind, before we take questions, okay? Just a sec. All right. So if everybody can see this, the question is, what should be done prior to using any hoist at the start of a shift? Is it pre-operational inspection, periodic inspection, load testing, or lifting 50% of rated capacity? And for those of you on an iPad, you're going to have to put your answer into the Q&A pane because I don't think the polling works on iPads. Again, what should be done prior to using any hoist at the start of a shift? Pre-operational inspection, periodic inspection, load testing, or lifting 50% of rated capacity? Well, Peter, it's split between A and B. 97% thinking A. Is A the right answer?
A is the right answer. Yep, you want to do a pre-operational inspection.
Great.
The periodic inspection is your detailed inspection. I mean, if someone were to do that, that's certainly wouldn't hurt. It would be excellent if someone did that at the start of every shift, but it's just not practical. But yeah, it's your pre-operational inspection, looking it over, training your users or operators to know how to do that. We have an excellent webinar, another 30 to 40-minute webinar on that goes step by step through each component. So certainly you want to train your operators up on that and how to do that, because it's going to keep them safe and they're not going to be using bad equipment.
Perfect. Excellent. Thank you. Well, for any of you that have any questions, please go ahead and put them in. We love to see them. We love to answer them. I do have a couple of follow-up things that I will be including in the email to everyone after the fact. Like I said, we'll have a recording link. And with the recording link, once you go and click on that webinar, you'll have access to all the other ones. We started this series back in February of 2013. And we do it on a monthly basis just to help promote safety. They're very educational in nature, not promotional. So it's basically Peter and a few other of our trainers, teaching you about different aspects of safety. So it's kind of interesting how many times you brought up different ones that we've done. But yeah, we have quite a collection now. So you'll be able to access that from the link I send you after this session. So there's no questions right now, Peter. Do you want to go ahead? And I think you have another slide to go. Perfect.
Yep. For those interested in continuing education, again, these webinars we do are little snippets of topics that we talk about. We have a great overhead crane training program at our Niagara facility in Buffalo. We even have the ability to certify through NCCCO. We are a testing facility for that. But we do go through all types of crane. We have 2 3-ton overhead cranes, so it's all hands-on. From flipping plates to lifting. You can see some of the pictures from structural shapes, bundled loads, maneuvering through obstacle courses with the crane, using a crane that is a 2-speed end trucks to 2-speed hoist, to variable frequency drive end trucks to variable frequency drive hoist, looking at trolleys, things of that nature. So we go through all that. The Qualified Rigger Workshop, we go through rigging gear inspection, from shackles to slings to cranes, things of that nature. Not cranes, excuse me, hoists, not cranes. And then we also go through basic rigging practices and how to do hitches and size up slings, to the advanced rigging like you saw here, and all, how to calculate weights, center of gravity, share of loads, and tie it all together and be that qualified rigger that really, if you're doing any type of rigging other than production lifts, that you should be a qualified rigger to do that. And if you're on anyone here that's in construction, OSHA requires that you are a qualified rigger, that you're qualified to perform the rigging that you're doing. And so the training is the start of that. By no means could we train on every type of lift like that, but you'll be able to get enough information from that course that it will guide you for your loads that you have to lift. As a matter of fact, a gentleman left that qualified rigger course and sent me an email and said, you know, I had a 110-ton machine that had to be lifted, and I looked at the rigging plan that they came in with, and before your course I wouldn't have had a clue what I was even looking at, and I realized there were mistakes in the rigging plan and the attachment points weren't right, and by taking your course we were able to sit down with the operator and the rigger and figure out a great lifting plan and calculate our tensions, and it went off flawlessly and it worked safely and perfectly. So great feedback I got from that. So just to give you an idea. We have overhead crane and hoist inspection, which we go over the entire systems and how to inspect the entire crane system and do a periodic inspection on your cranes and hoists, and we can certify you in that. We have static stepless controls, which is the next step after overhead crane. It's an older type crane controls and how those work and operate and how to inspect them. And then we have chain and wire rope hoist repair, where we tear down the hoist from every nut, washer, shaft. We go through all the Columbus McKinnon hand hoist and chain products and wire rope products in a week and show you how to repair them. And so whether you only want to come to chain hoist repair or the whole chain and wire rope repair is up to you, but we have classes throughout that we show you how to do that.
Okay, thank you, Peter, for going over all that. We got a couple questions that have come in. The first one is, do we make a beam clamp that can be used in applications where the side load would need to be greater than 5%?
No, we do not. We do not. We recommend another method to do that and a connection point to do that. So therefore, using a sling, or you're going to have your, if you need to do that, you're going to have your beam modified to put a connection point up there that, like a swivel hoist ring or something that is allowed to articulate so that the hoist can remain in line. Now, there is a formula. There is a formula. Again, this is way beyond this course. That using beam clamps. Let's say like in a low drift, that someone wanted to lift something up using those beam clamps. There is a formula that gets pretty in depth about line of actions and where your line of actions fall, and if it passes through the toe of the beam clamp, that it's okay to use because you're not side loading the clamp. But it's way beyond I can teach in a 30-minute session here. So in some instances, yeah, but you got to be qualified to do it. You got to do the calculations. You got to find your vectors and your line of actions to be sure that you're not side loading that clamp.
Okay.
So my initial answer would be no, but it's an engineered lift. Once we get it's to look at those clamps if they're going to do that, and in not all cases it's going to work. I just prefer the swivel hoist ring method or the slings that I showed you to do that with the protection.
Great. Thanks, Peter. Another question has come in. My understanding from the webinar is that any manually operated chain hoist can be used at any angle, providing the hooks are in line. There is not any angle limit. Is this true?
Well, we don't recommend going below a 30-degree angle. Okay, there are some. You can go horizontally, and then you can jump up to 30 degrees. It's a very good question. That's why I show how to calculate in this presentation to say you must know your tensions, you must know your shear of load, you must know your weight, that you have to do those calculations before you do that. When you get below 30 degrees, you start to worry about compressive forces on your equipment, and so therefore, again, you could have a load, the load may not hold up, or your pick point might not hold up. So that's a very good question. You probably want, if you're going to go below 30 degrees, you want to start getting into below the hook lifting equipment like spreader bars, some kind of below the hook lifting equipment to assist you in balancing that load out.
Okay.
And if you have to go below 30 degrees, it's the qualified person who needs to determine that. You know, is my pick point adequate that can hold those compressive forces? And then obviously, if we're at 0 degrees, what's a straight inline pull? You know, we don't have the tensions like we do when we're lifting at an angle. We're in a tensioning operation where the load is on the ground, so we're not really lifting, and that's a whole. And our rigging pocket guides actually show how to calculate that as well.
Okay, perfect, Peter. I'd like to go ahead and launch another quick poll. Just quick, on a scale of 1 to 4, with 4 being the most important, how important is it for your company to get personnel properly trained in the safe use, care, and inspection of rigging, hoist, and cranes? Would it be very important, somewhat important, or not important? And this really could be different for everybody, so we're just trying to get some feedback. Again, on a scale of 1 to 4, with 4 being the best or the most important, how important is it for your company to get personnel properly trained in the safe use, care, and inspection of rigging, hoist, and cranes? Very good. We appreciate your feedback. Thank you for that. You can keep voting for another second. Yeah, excellent. Thank you. Yeah, we're finding there's a greater growing trend for training, and it's, you know, it's something that companies are wanting to invest in more and more because they're seeing the need.
Absolutely. And these webinars are an eye opener for a lot of people. You know, even when we do our training, say, "Wow, I didn't know that. I never thought to even think of that." And or I had one guy on a wind farm come here and said, "I can't believe I did not get injured or killed the way I've been doing things. I just never thought of the things that you brought up to what to look for, and I can't wait to get back and change things up immediately because, you know, there's a lot of things that we're doing wrong, and so there's just a lot of it's nothing complicated, but a lot of little rules to rigging and things that if you just do one slight thing differently, it really changes everything up and can overload and quickly compound on somebody and result in an accident."
Right. Well, it's all about safety. We hope that these safety webinars are opening your eyes to a few things, or just, you know, able to educate you on some new things you might not have known. Well, this is it for our webinar for today. I just want to touch base quick. We've been talking a lot about YouTube and some other things. We are on social media. For those of you who are on Twitter or YouTube, Facebook, LinkedIn, Google+, we're on Instagram now too. Got a lot of great application shots on there. And we also have a blog. And if you go to our website, which we'll send you the link for, or you can see right in front, cmworks.com. If you go to our website, we have all those icons on the upper right-hand corner of the screen, and you can connect with us there. We have a safety blog, which we publish once a week, and write different articles. We've got 20 people in the company that write for that blog, over 140 different articles, mostly technical, on how-tos, and you know, some are product focused benefits, other ones are industry related, other ones are organization, association related, but a lot of it are customer questions and answers and things like this. So we love to connect with you. I'm the one that is doing a lot of the social media for the company, and I'd love to see you there. And as I did say, just to wrap up, you'll get an email from me by at latest on Monday of next week with some of the follow-ups that we talked about through the session. Thank you all for coming, and if any of you have any ideas for things you'd like to hear about in the coming months, we'd love to hear them. You can type them in the Q&A pane right now, or when you get my email, you can shoot me an email back and say, Gisela, I'd love to have Peter or someone talk about this subject. We love to hear those ideas. As Peter said, this month's subject was recommended by a previous webinar attendee. So thank you all for your time, and we wish you a very nice weekend.
Thank you.